Let's look at another example of implicit differentiation. I want to find dy dx if y squared plus 4xy equals 5y minus 3x squared. I'm going to take the derivative of both sides with respect to x. Let's start with the right side. It's just a tiny bit nicer. So if I'm taking the derivative of 5y, the derivative of 5 times a variable is just 5. But I took the derivative of this variable y with respect to x, so this picks up a dy dx. Likewise, I can take the derivative of 3x squared, power rule, so I can drop down that 2 and multiply. 3 times 2 is going to give me a negative 6. 2 subtract 1 leaves me a power of 1, or just 6x. I just took the derivative of x here with respect to x, so this is a dx situation. Dx is really just 1, so I have 5 times dy dx. That's the thing that I'm trying to solve for. I'm trying to find the change in my y values with respect to the change in my x values. I'm trying to find rise over run, or y prime. And I see it already there. Let's work on the left side of this equation as well. I'm taking the derivative of y squared. Well, the derivative of something squared is going to be drop that power, 2 comes down, take 1 away. Derivative of y squared is 2y. Since I took the derivative of y with respect to x, this picks up a dy dx. I'm also going to have the derivative of 4x times y. And I'm writing that as 4x times y instead of 4 times x times y, because this looks like two functions that have been multiplied together. It looks like I need to do the product rule there. So we could either do a little bit of scratch work, or let's do this thing in line. I have 2y dy dx, that drops down, plus product rule says take the derivative of the first piece, 4x, multiplied by the second, plus the first function times the derivative of the second. So I got f prime of x times g of x plus f of x times g prime of x. I'm taking the product rule there. Let's take those derivatives. 2y dy dx. The derivative of 4x with respect to x is 4. The letters match, so it's just 4. 4 times y, 4y. And I have 4x times, the derivative of y is 1, but I've taken the derivative of y with respect to x, so this picks up a dy dx. Let's multiply some things out. Let's combine some like terms. I've got 2y dy dx plus 4y plus 4x dy dx is equal to 5 dy dx minus 6x. Let's get everything with the dy dx on the same side. I already have the 2y and the 4x with that dy dx. Let's also subtract this 5 dy dx to the other side. Likewise, let's take everything that doesn't have a dy dx. Negative 6 is already in the right spot there. And let's move it to the other side. So let's take this 4y and let's move that over. So minus 4y. From here, I'm noticing that everything on this left side has a dy dx, so I can factor out a dy dx. A 2y had a dy dx, a 4x had a dy dx, and a negative 5 did. So by bringing everything that had that dy dx to one side, I could factor it out to isolate it, and now I can divide by this larger quantity 2y plus 4x minus 5. Dividing by that expression leaves me with negative 6x minus 4y divided by 2y plus 4x minus 5. So the derivative of y squared plus 4xy equals 5y minus 3x squared with respect to x, dy dx, is negative 6x minus 4y over 2y plus 4x minus 6. Let's check out some more examples of this stuff together.